D3L2. Take it away, Denny.
Welcome to this next section of the D3L2 vidcast and podcast. My name is Denny Lee, and I'm really happy to have Christina Taylor here for our next session about migrating from a data warehouse to a lakehouse with structured streaming and Delta Lake. But before we start, I really wanted to go ahead and actually allow Christina to introduce herself. So, hey, Christina, why don't you tell a little of the audience who you are and like how'd you even get involved in this data engineering space? But yeah, let's just start with who you are and a little bit about your history.
Yeah, sure thing. Hey, folks. I'm a data engineer today at Carvana, but kind of an interesting personal story. Originally had a background in teaching and education, graduated into a recession, worked in universities in career advisement for 3 years, could not afford paying rent in New York City on a teacher salary. So I got into data and analytics. The insight I've learned being a career advisor, I thought, oh, okay, this is hot. So let's see what's going on here. Started off as an entry-level analyst, made it all the way to analytics manager, but then realizing, okay, for people to do the cool business intelligence, visualization, data science stuff, you really need a strong data engineering foundation. So let me be that janitor with a keyboard. So I took a step to join the founding team at D+. So learned Spark streaming, structured streaming on the job, migrated from EMR to Databricks, migrated from Redshift to Snowflake. So fast forward a few years, grew to be the staff engineer for a fintech startup called Bread, came over to Carvana after the acquisition. So very strong startup mentality, really love the Spark distributed computing framework. So think about it, the code that you wrote are innately parallel. You don't have to think about distributing across multiple machines, partitioning, all that complexity is hidden behind the data frame API. So I've really enjoyed working with Spark. And Delta was Spark on acid, right? So
Very much.
I know if you've seen that shirt, it brings transactional nature to Parquet files. So it adds all these cool features like time travel and version controlling and safer overrides and replace. So really enjoy working with that as well. So here we are.
Okay, well, this is pretty awesome, and I'm actually sort of impressed by that fact. So let's go back actually just a little bit because I find your history very interesting. So you originally were going to be a teacher, and you hit the recession, which sucks, of course, but then you noticed that the hot topic or the hot career was within the realm of data engineering, and so as you were doing career advisement, and so then that's actually what got you involved in that into this this space.
Yeah, that's where it all started. So what can I say? Live like there is no tomorrow. Learn as if you are going to live forever.
I love that approach to approach to it because it definitely continues that push for the idea of self-learning, like, you know, where you're constantly educating and changing and updating yourself to based on the newest technologies and the newest pushes, which is really cool. And so then, okay, so you got involved. What ultimately led you into the realm of like even just Spark and structured streamings? I mean, I'm really happy that you wrote like the data frame API, which is great. You know, a shout out to the Spark community to help build that. But like, what got you to care about distributed processing in the first place? Like, you know, you because you jumped right to there right away, and I'm like, well, how did you get there? Like, what led you to actually needing to utilize something like Spark in the first place?
Yeah, so I'll tackle Spark and then streaming. So
Sure.
I became a huge advocate for open source technologies and open format as well. After seeing a lot of the opposite trends, say, in some of the more traditional industries. So I felt like with the Spark framework, first of all, the code you write is innately parallel. In the second place, you have the support of all the entire open source community for contributions, rather than just using particular patented technology within your organization. So that's extremely powerful, probably explains Spark's popularity and growth. And open format, and I think I'll touch on a little bit more when we talk about data warehouses. Also, I feel like it's like very misunderstood but necessary concept as of today. So the idea of owning your data and no vendor lock-in or keeping it whether on-prem or secure in your own cloud environment is really, really important. So a matter of fact, and it's this kind of thinking that contributed to the $500,000 cloud cost reduction here at Carvana. So I'll discuss that a little further,
Okay.
but there's huge opportunities for both performance gains and cost reduction here, which also ties into my take on streaming. So when I think the biggest conception of streaming as of today is people think about it as real time, always on, 24/7, $, but that's not necessarily always the case.
Right,
sure, streaming can be real time, but I think the most powerful aspect of Spark structure streaming is the idea of checkpointing and disaster recovery, and coupled with technologies such as AWS SQS, a notification system, you can achieve file detection and ingestion on demand, as well as this trigger-based streaming pattern.
Yeah, that makes a lot of sense. I mean, exactly to your point. I think one of the key facets that a lot of people forget about when it comes to things like Spark or structured streaming is that one of the most complex parts of this is actually the state management. Just actually understanding what files did you process or what rows did you process, and having a system that actually pre-built in that state management right from the get-go actually simplifies your life, whether you actually are dealing with real-time scenarios or dealing with batch scenarios. So actually, the fact that you basically can think about the problem purely in terms of latency, but the business logic stays exactly the same, right? I think that's a pretty powerful concept. And so I think this actually naturally segues to exactly what the title of today's session is, which is migrating from a data warehouse to Lakehouse, and with structured streaming and Delta Lake. Well, yeah, why don't you give your motivation about and your background in terms of, you're saying you're going to migrate from a warehouse to a lakehouse. So what was the infrastructure or the setup that you had in terms of data warehousing in the first place, and why? Let's just start with that. Like, what is the current, and then afterwards we'll discuss why the transition to lakehouses.
Yeah, for sure. Let me start with the business impact on what problems we're trying to solve with data. So being from an analytics background really gave me the sympathy for stakeholders. So my group at Carvana handles customer communications. So that's customer engagement, retention, workforce management, conversation, and AI, blah, blah, blah. So the crown jewel of our front-end services is called Sebastian. So that's the chatbot you talk to when you visit the Carvana website. Often your first point of interaction with a customer, and it would also route communications to relevant advocate. And so we keep track of all customer communications, and that goes into something called a com router service. That's a legacy monolith service that has a collection of a lot of different things that goes on, like, customer sends a chat, and the chat is assigned to an advocate, or customer click the escalation button, blah, blah, blah. But it's a lot of different things all mixed together. And as I said, this is a legacy service, and they were not designed for analytics use cases. But then people want to help Sebastian work smarter. So help workforce management to assign conversation more effectively. So we definitely want that insight. So what do we do there? Okay, so this was before we had a proper data engineering team. So the quickest and fastest turnkey solution is actually very commonly seen. And I've seen this across several other organizations that have worked in the past. So ClickOps quick turnkey solution using a data warehouse as a target. So for example, Google Cloud BigQuery is one of these targets. oh, so from the Google Cloud login service, you click a button, you choose a BQ table as a destination, boom, in a couple of minutes, and you have an analytics table. And I have to say that having worked with SQL Server, Redshift, Snowflake, Google Cloud BigQuery, and BQ is actually, in my opinion, one of the most powerful analytics data warehouse there is. And unlike all the others, it's truly serverless. You don't have to provision at all. Even some of the like serverless data warehouses like Snowflake, for example, it requires you to somewhat size the warehouse, right? You choose like small, extra small, and quite often there's a contract model. So you have to have some thought in mind, but with BQ, you can truly just pay as you go. And the pricing is also fairly transparent. So it all depends on how much data you process and query. For on-demand pricing, $5 per terabyte. And it's been pretty fast. And I've actually not had performance complaints. So you think, oh, what is the problem?
Yeah, exactly.
Right?
That invariably exactly why. Wait. This sounds pretty good. What? Well,
Yeah, right.
I'm a little
You keep
confused now.
throwing money at the wall, serverless, bottomless, right? So pay your way up. This is not a problem.
Oh, that's brutal. Serverless, bottomless. I think I'm going to take that tagline now.
So cost is not a problem until it becomes a problem.
Right.
But so one of the reasons why cost became out of control is that when you're using these out of the box sinks, so you don't write any code, right? But there's also very few customizations you could make. And at best, you could only partition that destination table by timestamp. BQ is smart enough to recognize that as a date time. So it's not really partitioning on that hard cardinality, but you can't do anything else. You won't be able to cluster or Z order by event name or event type. So resulting in every time somebody does analytics on that table, it's a full table scan. So think about like a 2 terabyte table. Every time someone does select star from table where event equal to something, it does a full table scan. So $10 per query. So that gets very expensive. But cost is only one problem. This target doesn't really have schema evolvement capabilities. As many data warehouses, it doesn't just add that. So if your event has a new field, it doesn't add it for you. That's not something that typical data warehouse can support. So we've been very lucky that this is a legacy service and the schema doesn't change a lot. So schema change using a new target and do a tedious backfill was just like a once in a year event. But when that happens, it's quite tricky and it's really annoying. Okay, so I talked about full table scans and not able to evaluate fields, right? And so we realized one of these jobs, because we need to recompute the metric every 5 minutes. So even though it is just on a 2 terabyte table, that job itself $1,000 a day. On a 2 terabyte table, it's crazy. Using DML, it's very tricky. In BQ, it's not like in Delta Lake, you can just do upsert when match update star, right? So it's very tricky, and there's a lot of things that are unsupported due to our business logic, resulting this $1,000 a day job for only a puny data set, 2 terabytes.
Okay, got it. Okay.
Yeah, so we're like, this is really unsustainable. So what do we do? So our first try was actually to have one separate sink for each event type.
Yeah, okay.
So,
okay.
So
no, I think I know where it's going, but please explain. This sounds a little iffy already.
Yeah, so and then people would keep requesting new event types and new tables. And we do use manifest to release these sinks. So Kubernetes config connector, but that quickly became a deployment nightmare. So a senior developer needs to be involved. You're messing with production GCP resources, and we just cannot keep up with the demand.
Right. Because basically, just to roll back a little bit, just to provide people context, the idea is that every single time anybody wants to go ahead and create something, generate a new topic of any type, basically it generates a whole new set of tables. You actually have to have somebody like a senior person. It's not automated. It's not metadata. And even if you could, now it's a maintenance nightmare because you have all of these tables to go keep track of. I'm sort of summarizing that context. Okay.
For sure. And the worst part is once you release a new thing, you're like, oh, wait, I got to at least have some historical data. And then you go into that all encompassing log router that has all event types, and you try to do a backfill.
Right.
But we're only interested in the JSON payload, and it's a structure type. And when your source contains so many different event types, your schemas don't match. Guess what I ended up doing? I have an Excel spreadsheet of a target table and a target schema, like maybe 80 to 100 columns. And I write an index match against the original table to generate the backfill SQL statement for me. I hate it.
Wow. Okay. I've done some pretty ordinary stuff in my past too. And yes, I think you and I can both compete when it comes to some funky SQL backfill statements. Okay, got it. Wow.
Yeah,
right.
You know how I feel. I'm a hardcore data engineer. Scala is the way. I already don't want to write SQL, not alone some Excel, VBA, or formatting stuff.
Oh yeah, no.
But, yeah.
Okay, sorry. This is story time, just for the sake of little, just for posterity and for fun. I actually, if you think generating from Excel is bad, I actually had worked in a system in my past. I'm not going to mention which system it is, but in my past where they designed the pipelines using the precursor to Visio.
Okay.
And the Visio code generated Perl code. And then the Perl code would process the data.
Wow.
So at least it was generating SQL code for you. Oh, SQL script, not a code. I don't want to claim SQL's the code. So yeah. So I could empathize with your pain, but it also is really enlightening that basically we still, back when I had done it, so I'm pretty much dating myself really nicely. But the fact is that we seem to keep reinventing the wheel and doing more or less the same type of hacks, even when we're talking about completely different projects. Like in my case, I'm saying I'm Visio and Perl. You're talking about Scala, but SQL, but BigQuery. Like, yeah, it's interesting that we're constantly shifting back and forth like that, like doing the same mistakes. I mean,
whatever works, whatever it takes.
Whatever works, exactly, whatever it takes. All right, so.
Yeah.
So this motivation is almost clear as daylight. Okay, in terms
I
of
haven't finished with all of my pain points.
That's right. You have not. I'm sorry. I forgot. Okay. Continue your pain points. I'm sorry. You're right. I forgot. We didn't even discuss this before.
Right?
Yes. Yeah, that's right.
I would already rented all day.
Exactly. I'm like, you should be done. This is already painful enough as it is. You're absolutely right. There's a lot more to this. Please go on. I'm sorry.
There was one last pain point was in the data export. Now, Carvana is a very interesting organization. We don't have a CTO. And our CPO's vision is for each engineering group to be run like its own independent startups. Great. So my team has like a team of people with very strong startup mentality, roll up the sleeves. We picked our own favorite cloud tool technology based on our skills and interests, and other teams did the same. So we ended up on all three clouds. So the engineering operational database is in Azure, and some SQL Server stuff in GCP. The communications team all on GCP, and the core analytics team on AWS. So it's come to the point where we need to understand how much business the company has done from a centralized perspective, and my comms team needs to provide data to other organizations. So we're taking data from GCP into AWS every day. So that 2 terabyte table I was talking about.
Right.
But there's actually 3 bills we have to pay. Painfully, I've realized this. So first, select something from big table, $5 per terabyte. And then we pay a BQ storage API cost, which is more than the network cost. They didn't give me a breakdown. And last, we pay a network egress. 12 cents per gigabyte from GCP into AWS. And the funny thing is when you look at the bill and it says network egress North America, I have an English degree. I looked at the GCP pricing page, which is pretty transparent compared to a lot of other providers. I had to write to support and to have him translate for me. Hey, this is my understanding. Is that correct? So we're actually paying, because of cross-cloud in nature, a global rate. So effectively shipping data from GCP into AWS, we're paying the same as if shipping data from North America to anywhere in the world except Asia and Australia. So that one export job costs us $200,000 a year. I was like, no.
Holy Nikes.
Yeah, open format. So we need to find like a better way to extract this data.
Okay. So the motivation is there. It's clear as daylight, whether it's the event availability, it's schema management, target efficiencies, or just like you called out, the data export, the fact that you've got talking about $200,000 a year. Okay, so, all right, motivation is clear. Now I get it, because even though you started off talking about how much you loved using BQ as a data warehouse, the overall operations, the overall infrastructure resulted in the fact that you need a data platform that goes way outside the boundaries of what a traditional data warehouse can do. And so this invariably, I guess, led you to thinking about needing to build a lakehouse per se, basically? Is that the transition, or did you make any of the steps before you decided that the lakehouse was the right approach?
A lot of factors went into consideration here. So I think one of the core principles is the open format. So I really like the idea of decoupling storage from the compute and from a specific vendor or technology. So actually, this was particularly relevant because I came from fintech. So our customers at that time was very adamant that each tenant would have its own AWS account, and that data lives securely in our AWS account, not in some other data warehouse provider's account. So that was extremely important for us. And we also like the idea of open format, because one of the considerations of data warehouses is very easy turnkey solution, great user experience, and there's usually no cost or low cost when you put data in. So the problem starts when you have these repeated compute. There's only so much SQL can do. And then when you want to take data out, that's where you start paying handsomely. So even if you don't want to use this anymore, there's a better product. So just the sheer cost of data export alone, that's very scary.
Oh, sorry, I muted myself by accident. So basically what it came down to is that before you even started that Lakehouse discussion, you are already thinking, I need to store this in an open format, so that way you can actually make sure you're not locked into any vendor, such that even if that's the tool du jour today, the reality is with how fast this industry is changing and we're introducing new systems all the time, maybe you want to use blah, right? And then this project blah is great. It's even faster, even cheaper. But guess what? The egress cost of getting that data out from the original data warehouse is so extensively expensive that now you're limited in your ability to use project blah just because the fact of the egress costs are basically kicking your butt.
Yeah, exactly. Super important consideration for us. And sadly, one of the very leastly covered aspect when people are evaluating these technologies, it's like worse than a divorce.
Okay, that's pretty brutal. All right, so let's switch gears. So then that invariably, I guess, led you to before the Lakehouse, to Delta Lake. Then I guess, like, did you is that what made you the open format, or did you start with Parquet first or JSON first? I'm just curious, what was the modus operandi for you?
Yeah, so we've worked on both semi-structured data and structured data in the past, and there was a lot of legacy systems that are still writing Parquet. But I think of Delta as like a supercharged Parquet files. So and it really enforces the schema. So it's not like that you can append two incompatible schemas together and just lay over them in a Parquet file and have to do this expensive merge schema calls every time. It's as a transactional in nature, so you don't have to worry about partially corrupt files. And it has schema evolvement capabilities, which was really important for us. So we don't have to redeploy a Delta sync every time the service wants to change schema. And perhaps one of the more powerful features we like is how easy it is to do an upsert. So on the Parquet table, if you want to do an update, it's like a 7-step process. You know, okay, create a temp, populate a temp, drop the table, rename the table. There's way too much going on. But with Delta, it's so easy that you don't think about it.
Oh no, I mean, don't get me wrong, that's pretty awesome. And so basically the features of Delta Lake itself, itself plus the openness basically allowed you to feel comfortable saying, we're not going to need to worry about those egress costs anymore. We have this one lake that basically allows us to put all of our data and then process and query our data against. So
exactly. So for what we ended up doing for the legacy service, so we first ship the data to cloud storage. We take it out from cloud storage. We have to pay network, but it's something that only has to be done once.
Right.
And because of structured streaming and this extraction is incremental in nature, it's not like every time anyone wants to do an event, I pay this BigQuery select fee plus the storage API cost plus network. No, so I only have to do this once. And once the data landed in the bronze Delta tables, like a few very interesting things we can do. So not only can we partition on event date, we can Z-order on event type. So it's like a multi-dimensional index, and the lookup is much faster. And we can do also interesting things that we're not able to do in SQL, and that's called star expansion in PySpark. So what we're really only interested in is just the JSON payload. So instead of analysts writing select JSON payload attribute 1, JSON payload attribute 2 repeat 80 times, so we can just use JSON payload.star and turn this into columns. So it's very simple and very elegant.
Oh, that's really cool. So basically, because of the nature of basically combining PySpark with structured streaming and Delta Lake, you're actually able to have that reliable store. And because of the JSON payload attributes that you're trying to call, even though we sort of bashed on SQL a little bit before, it's actually nice and simple now. So for any of the analysts that actually need to get the analysts that want to get access to it, it's a very simple SQL statement for them to extract this data.
Exactly. So we have an all-encompassing bronze Delta sync that's being incrementally ingested using structured streaming. We don't do it 24/7. We use trigger available now. So we update this bronze sync once an hour. And we do use a data medallion architecture here. So bronze, silver, gold. And so the people who are writing the silver and or gold jobs actually have a lot more understanding of what the attributes to look for a particular event type. So even though the bronze table is a little ugly, it has so it has 100 columns. Lots of them are nulls, but this is like overall a good trade-off between the number of things you have to develop and the cleanness. Okay, so ideally, probably one event group should have one destination. But as stated, this service really wasn't designed with analytics in mind. So, okay, so the schema registry and the publishing events to a queue, that's the holy grail. That's what every data team is after, that contract between consumers and producers. But at least by having the bronze, silver, gold data layer separation, we can shed some light on the data lineage.
That makes a ton of sense. And so, and incidentally, I do want to give you a call out that like even though the bronze may look ugly, honestly, that's the whole purpose, right? It's the raw logs are supposed to go there. So that way there's minimal impact on processing. So that way, in case you ever need to go back because the business logic was wrong or there's some a failure in processing, you'd always go back to the original source and reprocess it from there. And then subsequently, you know, as you called out in the Delta Medallion architecture, in which we're talking about like a data quality framework, where from bronze, silver, gold, where the bronze is where it drops down, silver is filtered, gold is basically the business aggregations or rollups. It basically allows your users to then to be able to go ahead and access comfortably that they're actually accessing reliable and cleaned data. That's what it boils down to, right? Yeah.
Exactly. And there are so many cool things you could do with Spark structure streaming that like a data warehouse sync, you will not be able to easily accomplish. So streaming aggregation and streaming deduplication. So because we have control over that pipeline, there's actually a lot of consideration that went into this design. So from the log router, there are actually several destinations you can choose other than BigQuery. You could choose cloud storage or PubSub, for instance. But if you use cloud storage as a native destination, so the file gets rotated every hour, so that's a huge latency requirement. And you also don't have a lot of control over the layout of the storage. Like you can't do things like lexical ordering for structure streaming optimization. So we tried PubSub, and technically you don't have to use Spark structure streaming. So there's a Python library that can ingest from a PubSub source, but we like structure streaming because of the fault tolerance and checkpointing mechanism. And we really don't want to worry too much about tuning the Python job and worry about, okay, so how many in a batch and that sort of thing. Like Spark handles that for us. And we actually used like an Apache Beam job, also open source technology, running on Dataflow, which is Google Cloud's managed streaming pipeline. So to copy that to the PubSub message to cloud storage, well, because we want that infinite retention and easy backfill. So PubSub doesn't retain messages forever, but analytics events is a mission critical data set for us. It impacts the way that we train Sebastian and the way advocates gets evaluated by their speed to answer. So we want to be correct as well. So a lot of balancing out between speed and reliability and scale. So we ended up exporting PubSub messages to cloud storage every 5 minutes. And so right now we do trigger the pipeline, the ingestion to run every hour. But another factor that we actually really like about structure streaming is that it's actually one unified API for both batch and streaming. So you use trigger available now for a batch style workload, and you use you comment that line out, one line change to go real time. And so all of our bronze and silver jobs are streaming aggregation in nature, because we know that all the events should be received within 5 minutes. So that's how the file rotation works. So we're able to compute data as they arrive near each other. So we're using watermark with a window of 10 minutes for deduplication, because PubSub ensures at least once delivery. So there will be duplicates, but we really don't want to do that df distinct call on a huge table.
Right. Yes.
So that streaming deduplication is very powerful, and also streaming aggregation. So in real time, if someone wants to look at a performance metric, so you could also use a window function to do that. So have this moving average. So it's really cool.
Yeah, no, this sounds amazing. So basically the idea from your perspective is like, you've simplified the code base significantly because of the fact that, you know, with the logic by which you think about streaming and the logic by which you think about batch basically is the same logic. There's no change in business logic outside literally a line of code that you comment out. And then, that way I think Rendell Shin had actually explained this, like when he talked about like Spark streaming all those years ago, about like I believe the term was continuous applications they referred to. Like I'm referring to, I think, a Spark and AI summit from like 4 years ago, where the context is basically what's great about Spark streaming is the idea that you don't actually have to think about streaming anymore. Like the business you're decoupling the business logic decoupling the business logic from the latency, basically.
Yeah, exactly. So like on the high level, these are the things we consider when we design a pipeline. So like what is the format of the data? Where does it come from? How often does it get updated? But more importantly, so the one-time historical load will be easy, but how do you accommodate new data? How do you avoid recomputing of historical data? And that's exactly what unstructured streaming offered us with these window-based functions and streaming deduplication and aggregation.
Got it. So I mean, sort of almost like a wrap up, then it seems to me like what it boils down to is that you've migrated, like the title's migrating from data warehouse to a lakehouse for structured streaming and Delta Lake. So structured streaming and Delta Lake, we've talked about in terms of structured streaming gives you the ability to have that, to be able to deal with batch and streaming at the exact same time. Streaming aggregation, streaming deduplication. These are amazingly powerful tools. Delta Lake gives you the reliability. But the crux of all this is that it's all open. And so from your perspective, the idea is that migration from that warehouse to a lakehouse really is because of the fact that because you have multiple clouds, because you have multiple like warehouses, all these different systems where there's egress costs, ingress costs. And so you're basically to prevent that lock-in essence. That's what boils down to is like, okay, if I switch to a lakehouse, I've got an open system, and then you're able to build whatever you actually need, as opposed to going ahead and being locked in saying, too bad, you're going to have to use the system for a while just because of the cost.
So it's not only the vendor lock-in, but cloud lock-in as well.
Right.
I mean, it's easy if all of your infrastructure, say it's in AWS, US in West 2. But the reality is, especially at bigger organizations, we're increasingly need to live with a multi-cloud environment. So that's where I think open format really shines. Got it.
Cool. I mean, this is probably a good end of the end for this particular episode. This is super interesting. Any like tidbits, any advice you want to give to people who actually are facing the very thing that you're currently doing right now, which is multi-cloud, multi-systems, migration from legacy? Any other little tidbits? Because this has been super interesting, super helpful. I just want to leave you the last little note, basically.
Yeah, I guess one of the most important lessons that I have learned is it's actually incredibly difficult to compare vendors or clouds. You're always comparing apples to oranges, and the cost and estimate itself could require a separate degree for it. So really, we should have one for cloud cost understanding or cost reduction. But I think I've been fortunate to be able to work in both AWS and GCP and understand some of the nuances when it comes to network, ingress, egress. But I suppose my advice is for anyone who's evaluating the technology. So think about not only how you will use it, but think about what the alternative would be and what the potential impact would be if you ever choose to leave this particular vendor or cloud.
Oh, thank you very much, Christina. This has been a wonderful session. You've been super helpful. So to any of the folks that are watching us on the vidcast or eventually on Spotify for the podcast, join us on go.delta.io/Slack if you have any questions. But Christina, I want to say thank you very much for taking your time to speak to me today.
Yeah, my pleasure.
D3L2.